This is the fourth in a series of videos on the sampling distribution of p hat, or the sample proportion. And this in some ways is a summary video. So let's look at what we know. Well, one thing we know is that under certain conditions that the p hat, that is the sample proportion, is an unbiased estimator of the population proportion p. And the key is that you take a random sample from the population. So we often use this abbreviation right here, SRS. SRS is just an abbreviation which means simple random sample. That's the first thing we know. The second thing we know is that we can calculate, remember p hat is an estimator, it's a process. So there'll be a certain sampling variability that can be measured by sigma p hat. That is the standard deviation of the estimator p hat, and that will equal to sigma p times 1 minus p over n. The key there is that the sampling variability is dependent on two things. That is, what is the true value of p in the population, and what is the sample size. And the third key issue is under certain conditions, the estimator p hat is distributed approximately normal. And what I'd like to talk now is to go over under what conditions is p hat distributed approximately normal. So the question is, when is p hat approximately normal? Well, there's both an easy answer and a hard answer. The easy answer is more or less true, and the easy answer is when the sample size is large enough, where n is large enough, without being too specific about what we mean by large enough. Now remember, n, small lowercase n, is always our symbol for the number of elements or observations in the sample. So that's the sample size. So if the sample size is large enough, then p hat is normally distributed. And that's kind of the way we think about it and normally talk about it. A more precise definition, or a harder answer, would be this, is that we say it's approximately normal under these conditions. First of all, if you take the sample size times the true value of p, if that's greater than or equal to 10, and the sample size times 1 minus p is greater than 10, then we say that it's approximately normal. And these two together are known as the normal condition. And let's just do an example of that, right? So let's say we have a case where p, the true value of p, was 0.2. So in that case, 1 minus p, the probability of failure, would be 0.8. And let's say if it's approximately normal. Well, if n is equal to 100, let's calculate n times p. N times p is 0.2 times 100, or 20. And let's see, is that greater than 10? It is. So that's a check. And then let's go n times 1 minus p, which is 0.8 times 100, which is 80, which is also greater than 10. So in that case, we would say that p hat, the estimator p hat, is approximately normally distributed. But let's look at the case where the sample size was smaller. So let's say the sample size was only 20. In that case, n times p would be 20 times 0.2, which would be 4. In this case, this is not greater than 10, so in that case we would say no. In that case, the normal condition fails, and we would say that the estimator p hat is not normally distributed.